To expedite the process of 4.07, we would be deriving or creating a formula for quadratic equations. We would essentially be showing you and working through as a class how we get the quadratic formula. So instead of actually doing it, there it is. So this is what we do using completing the square as a tool and going from there and seeing our quadratic formula and how that affects and how it is brought together. If you're interested in that, absolutely, but someone has done that for us and we know it works, so you don't have to blindly trust it, but you can figure it out. The main takeaway from this is down here, and this is what I want you to know because it gives us a few shortcuts if we so choose. So a quadratic equation can be written in the form y equals ax squared plus bx plus c, which we know as standard form. Our a value tells us the direction of opening, our c value was our y-intercept, and our b value didn't have as much importance until we started thinking about completing the square. Now, if we can't factor it, it can be solved for x, meaning what are the x-intercepts, by using the quadratic formula. And that quadratic formula, again, is negative b plus or minus b squared minus 4 times a times c, all under the square root sign, all divided by 2a. And that's when it's in standard form. Now, from all that work, which I haven't shown you, but is helpful if we know the x-coordinate of the vertex of a parabola is also the h value from vertex form. Remembering that vertex form and the negative is the default in the equation. So if we did that, if it was a positive, then this would be a negative h value. The extra hint here is when we work through all that, which you haven't, but here is our solution, is that the equation for the axis of symmetry can also be found from standard form. And we can fast track. And it is negative our b value in standard form divided by 2 times our a value. And so if anything, this is the main idea from 4.07. We would have spent a lot of time deriving it ourselves, but that is the main idea. So to prove it, or to look at an example, let's use the quadratic formula to sketch this parabola. So, quadratic formula. To find my x, I'm going to have, again, negative b plus or minus b squared minus 4 times a times c, all square root, divided by 2 times a. So I need to simplify and get number plus or minus a radical, unless I can take the square root there, all over a number. So let's look. Negative 8. 8 squared, 64. Negative 4 times negative 5 is positive 20, times negative 3 is negative 60. All of that is square root, all over 2 times negative 5, negative 10. Well, I can take the square root of 4. That works, it's 2. So that's going to break down into plus 2 all over negative 10, negative 8, take away 2 all over negative 10. Negative 8 plus 2 is negative 6 over negative 10, which can reduce to 3/5. Negative 8 take away negative 2 is negative 10 over negative 10, which can reduce, negative 10 divided by negative 10 is 1. I've got two x-intercepts, 1 and 3/5. Hey, that's divided by 5 already. Awesome. 1, 2, 3. I also know from standard form that I have a y-intercept, negative 3. Before, I would have taken my two x-intercepts and added them together. So my axis of symmetry, I would have said 3/5 plus 1 all divided by 2. So 3/5 plus 1 is going to be 1 and 3/5, or 8/5 divided by 2. Remember that 8/5 divided by 2 is really 8/5 times 1/2. 8 times 1 divided by 2 is 4, divided by 5 is 4/5. So my axis of symmetry is 4/5. And that makes sense looking at the graph because it's halfway between them. So that's how I would have done that. And then I would take that 4/5 and sub it back into standard form. Now, if I forget about that and use my new key, and that new key is that my axis of symmetry is going to be negative b over 2a. So let's fill that in and let's see. So x equals negative b is 8 over 2 times negative 5. Eight, 2 times negative 5 is negative 10. Top times top, so negative times 8 is negative 8, divided by negative is positive. So we have positive 8/10, or negative divided by negative is positive. And that can reduce to, whoa, look at that, 4/5, which is exactly what we had and we've seen. We would take that 4/5 and sub it back in to find our height, and then we could graph the parabola. I'm going to let you do that, but again, our main takeaway is that for our axis of symmetry, we can get that from standard form. So we can get it, and then when we factor it, or use a quadratic formula, now we have our two x-intercepts, our axis of symmetry. Take our axis of symmetry, which is the x value of our vertex, sub it back in.